Now that the setup is complete and we have our corpus, we can start the fuzzing process. So what you have to do is to clean up the old installation and recompile both the libexif and the exif frontend with the AFL compiler. So let's open our AFL container, mounting our target folder like always. Okay, we remove the old install folder. We go inside the libexif first and we do a make clean. Now we can rerun the configure script, but this time we have to define the compiler variables to use LTO. And we have, of course, to change the path of the installation folder where we want to install it. And we leave enable shared as no, like before. Make and make install. Now we have to do the same with exif frontend. Make clean. And again, the configure script. We define the C and C++ variables to use LTO as compiler. We disable shared library. We set the prefix where we want to install it. And we define where is our installed libexif library. Okay, we got an error because it is not able to detect pop-t. This is because inside our AFL container, we don't have installed all the dependencies. So what we can do is running an apt update, add install apt install lib pop-t /-dev. Now we should be able to configure the exif frontend. Make and make install. It looks all good, so we can finally start the fuzzing of our target. To do that, it's the same as before. So we run AFL fuzz. We specify as input our samples that are in this folder. We specify where we want our output directory, the seed that we want to use, and the software that we want to fuzz. And with the head, we tell to AFL to pass all the inputs here as our command line parameters. Okay, there is an error with the input folder. That is okay. Now we can already see some crashes. So what you have to do is just let it run for a while until you have some crashes, and then we can jump to the triage section.